Good morning. This presentation introduces an integrated cost, time, and quality performance assessment framework for major public infrastructure projects. The case study is the new international airport of Crete at Castelli. The central objective is to combine three dimensions that are usually monitored separately into one transparent and auditable decision support framework. Mega project performance is often monitored through separate indicators for cost, time, and quality. This creates fragmented information and can produce conflicting management signals. The central research question is whether these three dimensions can be combined into one transparent index, while preserving the meaning and diagnostic value of each individual component. The study addresses three methodological gaps. First, conventional earned value methods integrate cost and schedule, but usually treat quality separately. Second, a simple weighted average may conceal weak performance in one dimension. Third, actual deviations and disruption-adjusted scenarios are often mixed together. Our framework addresses these gaps through a quality-sensitive index, dual aggregation, and explicit scenario separation. The new international airport of Crete at Castelli provides a demanding test case. It is a national-scale public-private megaproject designed initially for about 10 million passengers per year, with future capacity up to 18 million. Its large terminal, long concession period, and complex civil, electromechanical, and operational interfaces make integrated performance control especially important. The project's baseline and execution path were affected by several external shocks. The COVID-19 pandemic disrupted workforce availability and supply chains. The 2021 Arkalakori earthquake required structural reassessment. This was followed by substantial inflation and material price escalation, while the later construction phase introduced complex electromechanical interfaces and additional resource constraints. The evidence chain was designed to be explicit and reproducible. Cost and schedule data were obtained from independent engineer reports and approved program updates, while quality performance was based on 125 inspection records. For every reporting period, all three sub-indices and both integrated indices were recalculated from the same source snapshot. The framework defines three dimensionless sub-indices on a common reference scale. Cost performance compares budgeted with actual cost. Time performance compares the planned and actual remaining completion time. Quality performance measures the proportion of inspections that conform to requirements. A value of 1 indicates target performance, while values below 1 indicate an adverse deviation. The three sub-indices are combined using both arithmetic and geometric aggregation. The arithmetic form allows partial compensation between dimensions, whereas the geometric form penalizes weak performance more strongly. With baseline weights of 30% for cost, 30% for time, and 40% for quality, the March 2025 results are almost identical. 0.893 and 0.890. Cost performance deteriorated progressively during the observation period, falling from the baseline value of 1 in January 2024 to 0.792 in March 2025. This indicates a material cost deviation. However, the index is diagnostic rather than causal, so the estimated effect of inflation is examined separately in the adjusted scenario analysis. Schedule performance also remained below target. By March 2025, the time sub-index was 0.874, equivalent to a 12.6% deviation from baseline. The gap reflects workforce constraints, long lead procurement, and complex electromechanical interfaces. The result points to targeted recovery actions rather than simple rebaselining. Quality remained protected despite the pressure on cost and schedule. Of 125 inspections, 123 were conforming, giving a quality sub-index of 0.984. The corresponding conformance rate is 98.4%. The Wilson 95% confidence interval ranges from 0.944 to 0.996, providing a more reliable uncertainty estimate for a proportion close to 1. Overall, the inspection and corrective action procedures prevented broader project pressure from becoming material nonconformance. The integrated index provides a concise assessment of the overall project condition. In March 2025, the arithmetic PPQY was 0.893, using weights of 30% for cost, 30% for time, and 40% for quality. Although quality remained strong, it could not fully compensate for the simultaneous deterioration in cost and schedule. The result therefore indicates a moderate overall deviation requiring coordinated management intervention. Sensitivity analysis examines whether the diagnosis changes under different stakeholder priorities. When time receives 50% of the weight, the PPQI is 0.881. When cost receives 50%, it falls to 0.861. When quality receives 50%, it rises to 0.909. Therefore, the weights affect the magnitude, but every scenario remains below the target value of 1. The weights should be interpreted as transparent governance choices rather than hidden technical constants. The adjusted scenario separates estimated external effects from observed performance. After accounting for inflation, cost performance increases from 0.792 to 0.911. The adjusted time index increases from 0.874 to 0.916, while quality remains unchanged. Consequently, the integrated PPQI improves from 0.893 to 0.941. However, this is a contextual scenario, not a causal estimate, and a residual deviation remains. The findings should be interpreted within several limitations. This is a single case study observed from January 2024 to March 2025. The selected weights require stakeholder validation, and possible dependencies among cost, time, and quality were not modeled. The external effect adjustments are scenarios rather than causal estimates, while inspection conformance is only a proxy for broader quality. Therefore, the framework demonstrates feasibility rather than universal validity and should be validated on additional projects before being extended to safety, environmental, or stakeholder indicators. The integrated framework produces three main findings. First, quality conformance becomes a formal performance dimension rather than a separate checklist. Second, arithmetic and geometric aggregation produce almost identical results, confirming that the diagnosis is robust. Third, adjusting for external disruptions improves the index, but does not eliminate the residual deviation. Overall, PPQI converts fragmented cost, schedule, and quality evidence into a transparent and auditable management signal while keeping the underlying dimensions visible for decision-making. Thank you for your attention.